Okay, let's talk about Spring Dependency Injection. If you're a Java dev, you're using this thing pretty much every single day. It's the absolute engine of modern Java apps, right? It wires everything up so you don't have to. But have you ever just stopped for a second and asked yourself, what is actually going on under the hood?
And that's the real kicker, isn't it? We all use it, it's fundamental to our work, but if you ask most developers to explain the step-by-step process, you get a lot of blank stares. That little @auto-wired annotation feels like magic, but how it works is often a total black box.
So why does this even matter? Well, it matters a ton when the pressure's on. And for a developer, there's probably no place with more pressure than a big technical interview.
See, an interviewer isn't just looking for a definition you pulled off some website. They want to know if you deeply understand the tools you use every day. A question like, so, tell me how Spring DI actually works. Well, that's not just a question. It's a test. And it's what separates the developers who just use frameworks from the engineers who truly get them.
To really nail this, we have to start with the one big idea that powers everything in Spring. Not just dependency injection, but the whole framework. It all boils down to this concept, inversion of control, or IOC. And it's a huge shift in thinking. Instead of you, the programmer, writing new MyServiceObject over and over again, you just don't. You hand over the keys to Spring. The framework now controls how your objects are created, how they're wired together, and their entire life story. You're giving up some control, for sure, but what you get back is an incredible amount of power.
The best way I've found to think about this is to imagine Spring's IOC container as this brilliant automated factory. You give it the blueprints, which are just your Java classes, and you tell it what you need. The factory then figures out the entire assembly line, finds all the right parts, bolts them together perfectly, and then just hands you a fully built, ready-to-go object. You don't have to build a car. You just ask the factory for one.
Okay, so with that big idea of the factory in our heads, let's walk through the play-by-play. What happens from the exact moment you hit run on your Spring Boot application? It all starts the second that main method fires. The very first thing that happens is the application context, our IOC container, our factory, comes to life. This is the brain of the whole operation, and immediately it goes on a mission. It starts a component scan, digging through your code, looking for any class with an annotation like @component, @service, or @repository. Now listen up, because this is a super important point that a lot of people miss. Spring does not start creating objects right away. No. The first thing it does is create metadata for every component it finds. Think of these as blueprints. They're called bean definitions. And as you can see, they have all the info Spring needs: the class name, the scope, what it depends on. But at this point, not a single object exists yet. It's all just a plan.
Okay, once all those blueprints are laid out, now Spring starts building the actual objects. But it's really smart about it. It does it in a very specific order. It starts at the bottom, with the beans that don't depend on anything else, like our repository here. Then it builds the things that need the repository, like the service. And then finally, it builds the stuff at the very top, like the controller. This whole process guarantees that whenever Spring builds something, the things it needs are already built and waiting.
All right, so the objects are getting created in the right order, but how does Spring do the injection part? How does it actually connect the dots? Let's dive into the mechanics.
The secret sauce here is a super powerful Java feature called Reflection. The Reflection API lets Spring essentially look inside your code while it's running. It can peek into your order service class, examine its constructor, and say, aha, this thing needs a payment service to work. It then finds that payment service bean in its container and passes it right in. So it's not magic at all. It's just some really clever engineering.
And that brings us to a huge best practice, something that interviewers love to look for because it shows you've got real-world experience. There are a few ways to get your dependencies, but senior devs, well, we almost always choose one method over the others.
And here's why. Constructor injection is just flat out better. When you declare your dependencies in the constructor, you're making a promise that your object can never be created without them. It's impossible. Your dependencies are guaranteed to be there, and they're immutable. Plus, it makes testing a breeze because you can just pass in whatever fake objects you want. Field injection, on the other hand, it hides your dependencies and can lead to some really nasty problems, like circular dependencies that'll have you pulling your hair out. Just always use the constructor.
But what if you have, say, two beans that both implement the same interface? How does Spring know which one you want? Well, it follows a very strict checklist. First, it tries to find a match by type. If there's more than one, it tries to match the variable name to the bean's name. If it's still confused, it looks for a bean you've marked as @primary.
And if all else fails, it looks for a specific @qualifier annotation to break the tie.
And you know, Spring's control doesn't just stop after it injects everything. Oh no, it manages the entire life of that bean. From the moment it's born in the constructor, to running special setup methods with @postconstruct, all the way to cleaning up before shutdown with @predestroy, the IOC container is in charge from cradle to grave.
Okay, now for a really deep-cut pro-level bit of info. Ever wonder how in a @configuration class, if you call an @bean method 2 or 3 times, you always get back the exact same object? The secret is that Spring doesn't use your class directly. It creates a proxy, a sort of wrapper, around it at runtime. This proxy intercepts any calls to your bean methods and makes sure that it only ever creates the bean once. Then it just returns that cached version every other time. Pretty clever, huh?
So after all that, why? Why go through this whole complicated dance? Because this process, this intricate system, is what allows us to build modern, large-scale software. It's what gives us the flexibility to swap out huge pieces of our application with just one change. It's what makes our code incredibly testable. And it's what helps us build systems that are easy to maintain and built to scale.
Okay, let's wrap this all up. We've gone deep. So the next time you're sitting in that interview and you get the question, you're going to be more than ready.
So, how do you take all this amazing knowledge and boil it down into that perfect, concise, impressive answer that shows you know your stuff inside and out?
Here is your perfect 4-step answer. You say, first, Spring scans the configuration to create metadata blueprints for each bean, which are called bean definitions. Second, it instantiates the actual beans in the correct dependency order, often using Java reflection to figure out what's needed. Third, it injects those dependencies into the objects that need them, wiring the whole application together. And finally, you say that this entire process, from creation to destruction, is managed by Spring's inversion of control, or IOC container. An answer like that, it shows precision, depth, and total confidence.
And really, that's the whole point, isn't it? Don't just be a developer who memorizes annotations. Be the engineer who understands the architecture. Because when you truly understand how your tools work on a fundamental level, you can use them better, you can debug them faster, and you will, without a doubt, build better software.